All right, we're going to factor quadratics. So otherwise, we're going to find the roots when a is greater than 1 this time. We have our standard form, which is ax squared plus bx plus c, which is 0. It has to be in this form for us to do this. This is our problem, and you can see a is 6, and so it's greater than 1. So we're going to do a method called the grouping method. There are all sorts of methods, but we're just going to use the grouping method. Alright, so the first step is to multiply my a and my c, and so 6 times 6 is 36. So when I start doing this, I'm going to go ahead and say 6x squared minus 13x plus 36 equals 0. I use this so I can do the factor sum method. I'm going to need the factors of 36 but the sum of 13. And it looks like, when I'm thinking of it real quick, it's negative 9 times a negative 4. And negative 9 plus a negative 4 is a negative 13. My thing doesn't want to write. Negative 13. Alright, so now I'm going to use these factors here and make a group out of it. So I'm going to rewrite this, and I'm going to put them in red so you can see what I'm talking about. So it's 6x squared. And so I'm going to say negative 9x minus 4x. And if you notice there are two red ones, if you sum them up together, the green negative 13x. Now, here's what you got to be careful of. We don't want to put 36 in here again. We're going to just put plus 6. We only use the 36 to represent our factor so we could get the grouping. Alright, so now I'm going to group these. So I'm going to group them in like this, and I'm going to group these over here. I want to find out what they have in common, so I'm going to use red for example. So in the first group, I'm going to try to see what they have in common and divide that out. I can take a 3 and an x out of both of those. And when I do, I get 2, because 3 times 2 is 6, x times x is x squared. 3 goes into 3, negative 3 times, and x is there. So let's do the other one. The other one looks like I can take a negative 2 out. And the reason why I'm taking a negative 2 out is because if you look at the 9, the term in the middle, or the sign in the middle, one's a negative, one's a plus. We want to make them both negative or both positive. And you can see in my green parentheses, that's this right here, it already is a negative. So I've got to make sure that when I take something out, it turns this into a negative. Alright, so here we go. I'm going to, let's see, we're going to take out a negative 2, looks like. And then when I do this, it looks like I'm going to get a 2x plus, no, I'm sorry, not plus this time because I took out a minus. It's going to be, and I want to do this in green so it stands out a little different than the other one. Let me erase this. Alright, so when I take it out, negative 2 goes into negative 4 2 times. We have an x still left over. Negative 2 goes into 6. That's going to be negative 3. Now, if you notice my green parentheses, they should be exactly the same. And they are. And they're supposed to be like it. What's in the red is one factor. What's in the green is another factor. So here are my factors. 3x minus 2. And the other one is 2x minus 3. There's my two factors right there. If I multiply these together, I should get my quadratic equation up here. Now remember, these are my factors. They're not my roots. They're my factors. So how do I find my roots? You know, where the x-intercepts are. So I'm going to rewrite this so you can see it on the next page. Alright, so I just transferred everything over to the other page, at least our factors. Alright, so I want to find the roots. Remember, these are actually set equal to 0. So I'm going to have to set each one of these to 0. And so it's 3x minus 2 equals 0, and 2x minus 3 equals 0. See how I set them both equal 0? And then I'm going to add 2 to both sides. That gives me 3x equals 2. We're solving for x, because we want the x value. Divide by 3x equals 2/3. So there's one x-intercept. Add 3 to both sides. 2x equals 3. Divide 2 to both sides. So x equals 3/2. There's the other one. So if we were to graph this, it would have 1 at 2/3 and 1 at 3/2, which is 1, and it would be a parabola like something similar to this right here. So these are our roots.